Okay, welcome back everybody. Today we're going to have a brief lecture on the new science. Our question today is going to be, how did the shift from traditional authority to empirical evidence during the scientific revolution pave the way for modern scientific thought, and in what ways did it challenge the existing social and religious order of the time? Okay, so grab a pen and paper or a tablet and let's begin. Okay, so the dawn of modern science. This is going to be one of the big developments that's going to come out of the early modern period. And it's going to be very transformative. And essentially what it's going to entail is a shift from ancient authorities like the Greeks and Greek philosophers or the Bible, and a switch to what are called empirical methods of discerning the truth. And I'll get into what that means in just a bit. So, as we've been alluding to, this is an era of a lot of transformation. So we're moving out of the Middle Ages and we are moving into the modern era. And the scientific revolution is a big step in this. Now, sometimes it's called the Age of Reason, like it is on this timeline. And it basically sits in between what is traditionally regarded as the Renaissance and the Age of Enlightenment, which will be the subject of our next lecture. And so it plays a pretty big role in that. Usually we date it mid-16th century to mid-18th century. Like with all things, it's a little bit arbitrary, but generally 1543, which is when Copernicus publishes his theories on the heliocentric universe, and 1687 when Newton, was it the year he died or the year that he published the Principia? Anyways, it's these periods of time. Arguably the biggest casualty of the whole thing was a new cosmology. Now, cosmology is probably a word most people are not familiar with, but it's an important concept. The cosmology is the study of the origins, evolution, and the overall structure of the universe. So basically, it's what you think of the way things are. All right. So when you think of like, well, what's out there? What and how did it get there? If you try to answer this question, you're offering a cosmology, and this has changed very many times over the centuries. You know, the ancient Egyptians had a view. The ancient Babylonians had a view that it came from a war between the gods. Some people have thought that the earth was suspended on a giant turtle. You know, all cultures, all civilizations have had a cosmology, an explanation for how things are. And the medievals also had one, and it was partially based on Greek science and partially based on the Bible. All right. And essentially what this posited was that the earth was at the center of the universe. All right. And surrounding it were all the visible planets and the moon and the sun, the stars, and the stuff we could see. All right. So you got the earth, then you've got the heavens, and then beyond the heavens, as they were called, you have heaven. And this is way out there. You can't see it, but this is where God and all the blessed saints lived and heavenly creatures, and this was the universe that medievals thought of. Now, before we start to think that people were very much into themselves, I've mentioned in a previous lecture, they didn't believe this because they thought that the earth was better somehow, but in a sense they thought it was worse. You can think of it as like a sink. The heaviest, grossest materials fall to the center, and the lighter, more refined materials stay on the outskirts. And so it was believed that the earth, yes, it's made up of the four elements: earth, water, wind, and fire. The heavenly bodies were made up of a fifth element that was somehow more refined, which they call ether. And then, the heavens obviously were spiritual, so they were even finer yet. All right, and this model had existed since ancient Greek times, and it's what people believed that the universe was like, that it revolved around the earth. Well, this is going to get blown up, and because the church had put its stamp of approval, although they'd done this relatively late, this model had only really come into acceptance by the church in the 12 and 1300s, so in like the Middle Ages. Still, the church had backed it, and this is going to cause a bit of a rupture between those thinkers who are going to switch away from the geocentric model, this model that the Earth is at the center, to the heliocentric model, the idea that the sun is at the center. And this is going to cause all sorts of tensions. It's going to challenge the church in many ways. It's going to, again, divide society. And so it's just another one of these transformative events that make up the early modern period. Okay. Now, the scientific revolution is going to cover a whole bunch of different areas, everything from the human body to biology to eventually mechanics and electricity. But really at its foundation, its core, it was an astronomical issue. All right. And it starts, most people start the scientific revolution with the work of Nicholas Copernicus, who was a Polish astronomer, then living in the Holy Roman Empire, which was part of, what we would call Germany. But technically, Copernicus was in Poland by today's maps. But anyways, Copernicus challenged the geocentric model. And Copernicus did this really for not a great reason. Copernicus just noted that the models that were then used to depict how the Earth moved, how the sun and planets moved around the Earth were quite messy. All right. So astronomers for a long time had tried to figure out the rotation of the patterns based on this notion that the Earth was at the center. And in the process, they had created some pretty complicated models. And based on this reason alone, Copernicus started to play around with it. He said, well, what if we move the Earth to the center? Excuse me, if we move the sun to the center of the universe. And though it didn't clear up every single problem, it made the models a lot simpler. All right, they still weren't perfect. There still were some questions that were unanswered, and there really wasn't any proof for this other than the fact that it was more simple. And so Copernicus published this notion that the sun was at the center of the universe, or the heliocentric model, and pretty much left it at that. Just it seemed to look a little bit better to him. It would take another scientist, this time an Italian, a man that you probably know, by the name of Galileo Galilei. And Galileo added some meat to Copernicus's ideas. Galileo is a really famous philosopher and scientist for a number of reasons, but one of his most important innovations was to use a telescope to observe the skies. Now, telescopes had been around for quite a few decades, if not centuries, by the time of Galileo. But they were mostly used for shipping and nautical sort of stuff, basically looking out over distances. Galileo began to systematically turn them to the skies. And what he discovered was that what Copernicus had assumed was the correct way, was indeed the correct way. And he came to this based on a couple of observations. Now, according to the geocentric universe, all objects revolved around the Earth. And this definitely was the way it appears from Earth, right? You know, we still say the sun rises. But as Galileo began to use his telescope, one of the things that he realized was that other planets have moons, namely Jupiter. He turned his telescope, which couldn't be seen from Earth, toward Jupiter and noticed that there was moons around Jupiter. You couldn't see the moon. You could see Jupiter from Earth, but you couldn't see the moons of Jupiter with the naked eye. And he noted that these objects revolved around Jupiter, just like the Earth's moon revolved around the Earth. And so that right there proved to Galileo that not everything revolved around the Earth. You know, if Jupiter had moons and they revolved around Jupiter, then presumably other planets had moons, and that if other planets are at the center of their own orbits, then this proves that this notion that everything revolves around the Earth couldn't be correct. He also noted from his observations that the universe was incomparably larger than what people had believed. You know, he thought maybe in terms of millions of miles. We now know that it's billions and trillions of miles and light years in between planets. But already from his primitive telescope, he could tell that the universe wasn't this self-contained unit that moved around the Earth, that it was actually really, really large. The Earth wasn't at the center of it. That in fact, all objects moved around the moved around the sun, at least in our solar system they did. He also noticed something else, is that the stuff that the planet's made out of was pretty similar to the stuff we see on Earth. As he looked at the moon more closely, he noted that the moon wasn't made of some superfine substance, and in fact it was pockmarked and had valleys and ridges, and wasn't this superfine material. And so, armed with these observations, Galileo began to publish his work. All right, so he wasn't just Copernicus speculating, he now had some scientific proof. And these works that Galileo published began to attract the attention of the church, who, as I said, was invested in this geocentric model. Several church philosophers in the Middle Ages had, based on their understandings of Aristotle and what they had read in the Bible, said, yeah, no, this is the way it is. And the church had essentially, made this an article of faith, the geocentric universe. And they didn't appreciate Galileo coming along and messing it up. And so this led to some tensions. Galileo was brought before the church tribunal, before the Inquisition, and forced to recant. But other people would pick up the mantle that Galileo and Copernicus had put down. And the next major figure in the creation of the modern universe was Johannes Kepler. And Kepler was from the Czech Republic, or what today would be the Czech Republic. And as I mentioned, even with Copernicus and his models, they still didn't quite work out. In other words, Copernicus was assuming that all things move in circles because circles are the perfect form, and so the planets must move in circles. Kepler began to experiment with what we call the elliptical orbit of the planets. And that is that the planets don't, in fact, move in perfect circles, but they move in an oval or elliptical type orbit around the sun. At certain points of the year, the sun is, the Earth is closer to the sun, and then other times it moves further out. And so this elliptical orbit was important. And to get here, what Kepler had relied on was astronomical observation and mathematics. All right? And so this is an important development, is that, you know, in the case of Copernicus, he's relying on some math. He's trying to figure out how we can simplify these models of the planets. He's not doing really any observations. By the time we get to Galileo is adding observations. He's also a mathematician, and it's Kepler who really brings these together. And he's using not only observation, but he's also using some sophisticated math in order to figure out the formulas and to explain things. Okay, and so the real synthesizing of not only the ideas about the universe, but really modern day physics would be the work of Isaac Newton, who's definitely one of the most important individuals who ever lived. All right. So Newton came along, and again, he's building off of these earlier folks, and he puts it together into one giant integrated system. All right, so he's going to integrate all of the findings of Copernicus, of Galileo, of Kepler, and he's going to unify them into one grand theory. And at the center of this is Newton's idea of the law of gravity. All right, this is something that Newton devised. The story is that he was away from school. He was in quarantine, on lockdown. There was plague that had broken out in, I think it was Cambridge. I think he was a Cambridge guy, if not Oxford. Anyways, he was from home. He was sitting in his garden. He was kind of in a bit of a trance, daydreaming, and thinking about Galileo and thinking about Kepler and Copernicus. And he sees an apple fall. Now, I don't think the apple actually hit him in the head. That's what I saw in the cartoons, but I don't think it hit him in the head, but he saw the apple fall, and everything snapped into place for him. He had an aha moment. Essentially, what he began to realize is that the same force that was pulling the apple toward the Earth was the same force that was holding the planets in place. And he supposedly came up with his idea of the law of gravity based on this. And the law of gravity applied not only to objects on Earth, but also in the universe, and basically anywhere. Newton thought anywhere that you had physical objects, his law of gravity would apply. All right? And it's a complicated law, and I'm not a math guy, so I'm not going to attempt to explain it or pretend that I could explain it. But he also added other laws to this to help him explain things. He added the laws of motion. An object at rest will stay in rest unless acted upon by an equal and opposite force, I believe it is. And Newton really gets credit for this aha moment of using not only observation, but science and math, bringing it together into a system that would essentially explain almost any question that you had in physics. All right. Up until this time, the realm of physics had been divided between people who studied outer space because it was assumed that in the heavens, a different set of laws would apply. And on here, we had our own set of laws based on the four elements and so on and so forth. But with Newton, this all became incredibly simple. If you understood Newton's four laws, you could essentially explain any physical problem that you had. And people at the time really recognized this. Newton would go on to not only be the father of modern physics, but at his time, the greatest scientist who had ever lived. And his ideas would have impacts in many other fields. This model that he develops of combining observation and science and mathematics together into one system would have profound effects. All right. And so one of the things that kicked off the scientific revolution is this new appreciation for empiricism. And again, this is a fancy word, but it's an important word. Empiricism is a method of science where knowledge is acquired through sensory experience and systematically validated by observation and experiment. All right. Now, in the Middle Ages, people did science, and in the ancient times, people did science, but a lot of it was based on speculation, on philosophy, on armchair methods, essentially thinking without actually doing. All right. And so Greek science and Roman science and medieval science tended to be very much, and you can make some very impressive discoveries, but it tended to be weak on experimentation. And one of the things that the scientific revolution, dating all the way back to Galileo, who did experiments at the Leaning Tower of Pisa, all the way to Newton, was this idea that you had to do experiments and you had to make a lot of observations and keep records and measure and quantify. And what these thinkers of the 17th and 18th century did is they began to craft a method for discerning what was true and what could be validated as true. And this was the scientific method, and it combined this empirical method or observation. It combined mathematical modeling, and it combined that with testing, prediction, and revision. All right. And so really what the thinkers of the 18th century thought that they had stumbled upon was a formula for figuring out if something was true or not. All right. And so again, it starts in the realm of physics or astronomy, but there's no reason that you can't apply the scientific method to medicine or to engineering problems or to biological problems. All right. And so this was a method for determining whether something was provable or not. And of course, the last step in this whole thing is that you need to publish. All right. You need to refine and revise and then to publish. And the reason for this is not only so that your ideas get out there, but so that other people can try your experiment out. And if if dozens and dozens of people are doing your experiment and they're coming up with similar results, we can be pretty sure that we have stumbled upon a scientific truth that can't be disproven. All right, so that's part of the idea. And this proved to be a very powerful tool that really hadn't existed in ancient times. Now, this era is sometimes called the Age of Reason. And part of what they meant by the Age of Reason was being skeptical toward earlier notions. In other words, once people realized that Aristotle or the Greeks could be wrong about how the universe was constituted, this important question, how could we really be sure that they were correct about other things, right? I mean, maybe they were correct, but there was this almost a skepticism toward received knowledge. In other words, if we were going to accept something as absolutely true, it needed to go through this scientific method. All right. And so this era becomes really associated with skepticism toward old beliefs and passed on knowledge, right? We want to figure out what's true and what's just an old wives' tale that's been passed down for 100 years or for 1,000 years. All right. And so part of this is this appeal to reason, that something needs to be validated, and also skepticism toward existing models. Okay. Well, this was going to have profound changes on the way that people thought about themselves, about the universe, about the future. Had really, really profound changes. So one of the first things is that it blew up the previous model, right? One of the most fundamental things that humans have is their cosmology. You might not think of it, but so much of what you believe about the world is determined by how you think the world is, or how you think the universe is and operates, right? People who live in a universe where, maybe there's a belief in dragons or magic have a very different idea than people who believe in a universe that's governed by universal laws, okay? And so a lot of the universe was demystified, and I'm not implying that medieval people thought that there were dragons in outer space, or I'm not saying that. I'm saying that just the way that you look at the universe is so fundamental, all right? And so if you believe that a universe is governed by natural laws, you're going to think about the universe in a different way than someone who believes that maybe there's more divine intervention. All right. Maybe you'd be more likely to pray for better weather if you thought that the clouds were governed directly by God instead of by God through natural laws that he doesn't really change too much. All right. The universe was larger. People felt a lot smaller after Newton. It wasn't this tidy thing where we were at the center. People realized that they were kind of on a giant rock flying through space. That wasn't particularly important. It wasn't the center of the universe. And so this really changed people's perceptions. Now, you may think that maybe people suffered from more anxiety as a result of this, and maybe some people did, but for the most part, it was an age of optimism, all right? So one of the big cultural changes was the growth of secular thought. I mean, part of this had, these ideas were still being challenged by the church in the 17th century. Galileo had been brought before the Inquisition. And so it was really the church had come, the Catholic Church anyways, had eventually accepted this, but it did so kicking and screaming. And the people who had put these ideas forward weren't churchmen. They were secular scientists. And this was a big change because in the Middle Ages, most of the philosophers, and they were good philosophers, and they were smart people, but they had been churchmen. But now we start to see secular scientists becoming the leaders of a new movement. And in some cases, these folks are going to be skeptical toward the church. All right? And this skepticism toward revealed knowledge that I mentioned, also, some people begin to turn this toward not only science, but also toward religion. And so there's an increasing skepticism about things that are mentioned in the Bible or things that the Catholic Church is going to claim. All right? And this is going to have a big impact on culture. The Middle Ages was a time when the church had immense amounts of prestige, and that was certainly damaged by this. And so for many people, the Bible itself was something that was open to critique, open to skepticism. All right? And this is going to have profound impacts on society, as some people are going to begin to move toward a more agnostic position, something called deism we'll talk about in our next lecture. The scientific revolution has historically been looked at as the gateway to the Enlightenment, which is going to be the next section we're going to look at. All right, so it's going to, in many ways, it's going to be, the Enlightenment is Act 2 of the scientific revolution. Where it's going to be the same is that it's going to have the principles of reason. All right, so this idea that you need to do observations, you need to use these empirical methods, you need to be skeptical about received knowledge. But where it's going to differ is that the Enlightenment is going to be more concerned, they're going to have a big respect for science, but they're going to be more concerned with society. Essentially, what the Enlightenment is going to do is try to turn some of the tools, like the scientific method, like this appeal to reason, like this skepticism toward revealed truth or truth that's been passed down. They're going to take that and bring it into the social world of humans. They're going to begin to examine politics and the economy and society and law and all of these more human elements, where the scientific revolution was more concerned with the physical world around us. Okay, well, what I would like you to do is I would like you to consider this question. How did the shift from traditional authority to empirical evidence during the scientific revolution pave the way for modern scientific thought? And in what ways did it challenge the existing social and religious order of the time?